But it's really nice to be here and to talk about something that I feel quite fairly passionate about, because we live in a world where science is so dominant, and science really does give out a very strong message of, I guess there's various words to describe it, but it certainly is pretty anti-God in so many respects, and that hurts me as a Christian. I like to think that my faith is not at all inconsistent with the science, with the findings of science as revealed by the tools of creative exploration that God has given us. So today there's two images here which I want to kind of kick off with. And the one on the left, of course, is William Paley. Lovely engraving, actually much more elegant than this engraving of Charles Darwin. Actually, I think partly the quality of reproduction is not so hot. But Paley was a natural philosopher. He was a physician. He was a clergyman. And he wrote his book, Natural Theology, which I'm sure some of you have read part of or certainly heard of. Evidences for the existence, attributes of the deity collected from the appearances of nature. Lovely title, really, a bit long. That was published in 1802, and basically most people in the Western world would have essentially taken Paley for granted as one who basically saw the evidence of God in the created world. And it wasn't until 1859, when Darwin published his Origin of Species, that there was a rumbling, growing concern or unrest about the straightforward Paleist view. But Darwin basically has published his work, and of course that was already a huge turning point for the Western world in terms of explanation. Did there need even to be a God? Of course, Darwin and of course those that subsequently followed him with pretty hardcore naturalism were really saying that we don't actually need God. As science tells us that we have got an adequate explanation as to the world, particularly the living world, without actually recourse to a transcendent being. So those are, in a sense, those two worldviews are in mortal conflict, and they remain so today. The Paleist view, which is that if we look at creation, if we look at the world around us, can we not see the handiwork of God, versus the modern Darwinist view, which of course says we can explain it all without actually having to invoke a transcendence. Now, just perhaps to help with, this is a different, very sophisticated computer that I think, no.
Just use the keys.
The keys. Where are the keys now?
Bottom right.
Bottom right. Oh, okay. What I want to do is just quickly, I think most of us have wrestled with the creation texts and wondered just how we should take them. And of course, a very straightforward way is simply to take them literally, read them literally, which of course we have to. We do read it literally. But what are the principles of interpretation? And this is how I deal with it. So there's a few slides here before we get into the science. I thought it might be helpful, may not be, in which case just go to, drift away. But I think the general principle is to be conservative. In other words, try and be as true to the text, to the original meaning of the text as possible. And we would ask, what would have been the primary intent of the author? Would the author's intent have been to actually develop or reveal a science of creation? Would that have been of interest to the Israelites 15 to 1200 BC? Probably not. And what were the critical issues that faced Israel? Well, of course, it's interesting if you take the creation text, particularly the days of creation, you can link them very easily with Deuteronomy 4, where it said very, very strong, make certain that you do not sin by making yourselves an idol of any form at all. And in a sense, there's a list there of the main categories of creation that are actually addressed in the Genesis chapter 1 narrative. It's quite important that. So it's man, it's humans, it's animals, it's the reptiles, the fish, it's the astronomical domain as well that's addressed there. And it seems to me that a much more fruitful way of reading Genesis chapter 1 is to actually see those days of creation as dismissing the very gods that were surrounding the Israelites. They were called into monotheism, and yet they were surrounded by the gods of light and darkness. They were surrounded the sea and the sky. All those are basically gods that were part of the pantheon of polytheistic practices. And they are dismissed by the resounding declaration that they are all created by the one true God. So by the act of saying they are created is actually saying don't worship them because they are not God, they are not divine. And so I think it's important in terms of the narrative form, and right through Scripture we've got so many different narrative forms. I don't think we have TV commercials, so I think that's a bit out of it. But we have comedy, we have legend, we have epic, we have tragedy, we have proverb, history, we have poetry, we have legal language, Jeffrey, Romans. We have instruction manuals for living, we have symbolism, we have romance, and so on. We had graffiti, I think, in Daniel, almost. And so on. And of course, you've got to, and it's really important to actually honour the narrative form. And the danger of trying to get science from the Genesis narrative is this: the secular scientist is happy to read the creation text literally through the eyes of science, and then rightly conclude that it offers a naive, pre-scientific explanation which we now have proper explanations for, and then proceeds to reject all of Scripture as fable. Now I think is a tragedy if that happens. And I think the other thing that's really important is that if we try and read it as a scientific narrative, as a science narrative, I think there are too many things that tell us don't read it that way. For example, it begins with watery chaos rather than a burst of light. Two quite different accounts of the creation text are given in chapters 1 verses 2. There's a strong suggestion of an ancient pre-scientific cosmology, the heavens above, the earth and the underworld, the firmament and so on. And the natural order is scrambled as if unimportant to the author, so the vegetation appears before the sun. Much of the natural world is left unmentioned. There's no mention of the microbial world, which is it's the most dominant living part of the world. For days 1 to 3, the morning and evening occur even before the sun is put in its place, and so on. And so those are really sort of, I think, telling us, look, we're not going to get science out of it, we're going to get something vastly more important. The other thing is, I think the creation text has got a very different narrative feel to it. It doesn't have that gritty, earthy feel in contrast to the unmistakably historical flavour of the resurrection narrative. You read the resurrection narrative, either you believe it, and it's encased in a very strong sense of time, space, history, or you reject it. But I don't think you've got the option of doing what the liberals would say was, we get the resurrection feel, even though, just simply because Christ was such an inspirational human being, so we can, in a sense, read resurrection to his life because he gives us such a good feeling. I don't think that's an option for the Christian. I think that is a betrayal of biblical Christianity. And so I see, personally, I think the Genesis narrative, creation narrative, reads very differently to the type of narrative that we read, that we use in the Gospels. So I don't know whether that helps, but I wanted to make those points because it does free us if we're not having to get our science out of Genesis. And I know that some are followers of creation science, and there's a lot of There's a lot of literature on it, but it does worry me. I think it forces young people, particularly going through the educational system, to take up a defensive position when they don't really need to. But that's another issue altogether. I don't want to go into that today. Paley takes us out onto the heath. He does 2 thought experiments. First one is he says, imagine going off out into the heath for a walk and you stumble, you hit your toe. That's my good old leather shoe there. I thought you'd like to see that. It's a nice shoe. It's done many years of faithful service in the garden. Started off posh, but now it's pretty worn out. But stumbles across and you pick it up and you find it's a stone. And Paley asks, was there any special explanation required to actually have this piece? And he says, no. All that happened was that it fell off the mountainside and it tumbled down and got broken and fragmented. And there's no special explanation required to account for this object called a piece of rock. However, if you did this, he said the second thought experiment is where you stumble across something else, you pick it up and you find it's a pocket watch. Now, how do I explain this? And he has a lovely little piece here which he says this: it must have had a maker. There must have existed at some time an artificer or artificers who formed it for the purpose for which we find it actually to answer, who comprehended its construction and designed its use. And that's, I don't think we can deny that. There's no other way that you're going to get this pocket watch to come into being unless you actually do some cunning design work. So 2 very different explanations. The first one requires no particular explanation. It just is a bit of rock that happens to have been there as a result of the natural processes of nature. But this one does require us to think, how did it come into being? And I'll show you the next slide, might be. Before Darwin, the functional design of organisms seemed to argue for the existence of a designer. It was Darwin's great accomplishment to show that the directive organisation of living things can be explained as a result of a natural process, natural selection, without any need to resort to a creator or any other external agent. Now, that's of course materialist Francisco Ayala, and created his book Creative Evolution. And basically, if you listen to the voices that are post-Darwin and that are naturalistic, then the argument goes something like this: we have a mechanism that actually gives us something as complicated, in fact much more complicated than a pocket watch. A pocket watch is a pretty simple object. It's more than an object, it's a piece which has a purpose, as a function of telling the time, and it's been created for that reason. The sort of analogy is that if from Paley's point of view, is that the living world, and he goes and he has some lovely pictures. I haven't got them on the screen here, but if you look at his book, you'll see that he has some lovely engravings of various things that were to him a kind of pocket watch analogue of complex, purposeful objects, like the eye, like the joint, like the beak, like the whole range of things that he sketched and put into his book. And the counter-argument to that is that we actually have a mechanism that gives us all these things, complicated as much or more, vastly more than a pocket watch, but we can get them without actually having to have an artificer, a person who deliberately actually makes them to achieve a certain purposeful end. Here's another one. This is John Levy's. Only natural selection comes close to omnipotence, but even here, no intelligence, foresight, ultimate purpose, or morality is involved. Natural selection is merely an amoral force, is inevitable and uncurious gravity. So these are the tools of creativity that the naturalist calls on. Now, I'm not going to go into Darwinism. I'm not a scholar of it, but I have obviously read a bit about it. Here's another one, but again to show you where the materialist or the naturalist stands in relation to creativity. Even today, a good many distinguished minds seem unable to accept or even to understand that from a source of noise, natural selection could, quite unaided, have drawn all the music of the biosphere. Indeed, natural selection operates upon the products of chance and knows no other nourishment. So you can see it's a strong claim to replacing anything that would hint of a purposeful, mindful creator. Dawkins, natural selection, the blind, unconscious, automatic process which Darwin discovered and which we now know is the explanation of the existence and apparent purposeful form of all life, has no purpose in mind. Again, you're very strong. You cannot have purpose in the naturalistic framework because there is no purposeful mind or prime mover behind the whole living show. It has no mind, no mind's eye. It does not plan for the future. It has no vision, no foresight, no sight at all. If it can be said to play the role of watchmaker in nature, it is the blind watchmaker. So that was Dawkins' grand pronouncement. My wife is very fond of birds, and she took this photograph. It's a lovely picture, but and I want to just comment, take Dawkins a little further than what perhaps he would want us to do. Dawkins argues, for example, the going back just to the vertebral. Well, we know from the paleontological record that life, if you come up through the Grand Canyon, life began fairly simply. Now, there's no such thing as simple life. That's the first thing. So, but we find, if we go back to the Precambrian, to the Cambrian, and to the Post-Cambrian, right through, we find there is an evolving complexity of life forms. Now, as I say, no life is not complicated. But Dawkins takes up the idea that the eye probably started, and it's probably possibly true, that it started very simply just as a little smudge of light sensitivity, and that it progressively developed through the various forms into the rather wonderful vertebrate eye, which you can see there. And again, I'm really trying to stress the issue of can you explain this complexity and purposeful function without recourse to purpose? Because what we've got is something that sees, and it obviously has been put together to give us sight. We can't. I mean, it's not there just as a chance happening. And Dawkins says vision, and of course he's really arguing that you can basically, it's just little steps of improvement. And okay, that's not unreasonable probably. Vision that is 5% as good as yours and mine is very much worth having in comparison with no vision at all. And I think we would agree with that. A simple, rudimentary, half-cocked eye is better than none at all. It's true of that. Without an eye, you're totally blind, and we agree with that. He then asserts that part of an eye is better than no eye at all. An ancient animal with 5% of an eye used it for 5% vision. Now, I argue that that is actually a fallacy. And why do I say that? Well, here's a little cartoon to actually illustrate. He's taken off without the propeller. He didn't have quite... Now, it's a very primitive aeroplane, but it was a complete aeroplane. You cannot have the plane taking off if it's got the critical part of it missing. So we can talk about primitive flight, we can talk about primitive vision, but you've still got to have an integrated system to give you even primitive vision. So I believe Dawkins is wrong when he says that, but of course he has to say that in order to be watertight in his naturalistic argument. Of course they did take off the propeller and they got off the ground. But the story really of naturalism is that we can go from basically primordial conditions that are simply nothing more than just lots of energy, lots of mass, what I call giga energy, giga mass, and giga time, and you end up with Adam and Eve in the garden. Well, that's a possibility, it seems to me. And of course that's out of a textbook that high school, university, stage 1 students would actually use regularly. And I'm not saying that the flow is not necessarily wrong. The question is, does it happen of its own accord without an input, a profound, informative input from transcendent being? And that, I think, is the big issue that we have to address. The issue of an evolving biosphere is something that we can address scientifically to a fair degree, and I don't think there's any need for Christians to get uptight about an evolutionary unfolding of life from relatively simple through to complex. I don't think we need to get uptight about some might, but I don't think there's any need to. I think the issue is the critical issue. Has it unfolded entirely of natural causes, or is there a transcendence that is basically guiding the whole process? So I'm going to give you a few examples of this kind of stance that, again, naturalism takes. The whole course of evolution can be regarded as a geared and cooperative dissipation of energy. This is Peter Atkins, who's a physical chemist at Oxford University. You'll hear him occasionally on the BBC World Service, actually, on radio. I must admit, he makes me a bit angry, quite honestly. Every stage of evolution, including the steps that gave rise to complex molecules out of simpler ones, to people out of slime, and the processes involved when species are confronted with competition, proceeds by dissipation. So he's kind of got this grand idea that given lots of energy, and its dissipation, you can end up with, well, us here today. Molecules did not aim at reproduction. Well, because we know that. They stumbled upon it. Accretion of complexity reached the point where one molecule was so structured that the sequence of reactions it could undergo under the causal pressure of dispersal led by chance to the formation of a replica. At every stage of replication, there was opportunity for modification because slightly different, smaller molecules were in the vicinity and could be incorporated. Many of these daughters may be unviable or less successful at replication than ancestors and sisters, but some were more successful and flourished into elephants. I'm not sure why it's into elephants. But anyway, that's Peter Atkins. It's pretty powerful stuff. I visited the Field Museum in Chicago back in 2000. I was over there for another reason, and it's a pretty big, pretty important museum, and they had a big display of dinosaurs there. They were one of these, a major, well, it was huge, but I mean, dinosaurs aren't pretty large, but it was a big show. But I went to the it's called the Life Through Time Tunnel, which was a really interesting display, which made me a bit mad, quite honestly, because this was part of it, and they had these molecules popping up. And here we've got sort of energy, we've got water, and we've got a little molecule popping up, and then showing you how life could have begun. And of course, it's a huge issue, really, the origin of life. It's a big issue. And this one really got my, this was Stanley Miller's 1953, his experiment he did with his supervisor, Harold Urey in Chicago, University of Chicago. And they basically sparked a mixture of water, methane, hydrogen, and ammonia, and they got out this sort of broth here. They got some amino acid, which of course are the building blocks to protein. proteins. And the display, which was really designed for children, especially because it ended with some very colourful sort of things at the far end. Breakthrough in 53 let us imagine life's beginning as a natural event. And Miller's experiment broke our imagination barrier. Its message, life could begin from chemical reaction between common materials found anywhere on Earth. So it was pretty good stuff, pretty strong stuff really. And of course it just continues. I mean, I've just picked these out of the newspaper, the Herald. This is the latest one. Big praying may have begun life on Earth. That's pretty exciting, isn't it? Big praying. And everybody can relate to a praying, can't they? I mean, we have prayings almost, well, you try and avoid them, but, praying is a great term to use, really. So exciting. This one here, Milky Way rife with planets and habitable zone. Rock reveals likelihood of life on Mars. That's a bit old. I'm not sure they're quite so confident about that now. But and this one here, I can't read it. The resolution's not good enough. But and so it's right before us. We're being washed with massage with this message that if we could only get over there, we'd soon discover that. Now, I'm not saying that we Christians should be concerned about finding life elsewhere. I've got no particular view on it, but it's part of the propaganda is that you can just base lots of energy, lots of time, and lots of matter, you end up with life. And of course, life's vastly more, deserves more. I think it deserves a much more expensive praise. That's my own view, and I want to talk about that in a moment. And the reason, I don't know how many here, can I perhaps ask how many here have read anything of Michael Polanyi? One, George, and one at the back. Anybody else? Now that is a tragedy for Baptist. I'm just joking. And it's a very difficult book to read. But there were two papers that he published in 67 and 1968. One was called Life's Irreducible Structure, and the other one was called Life Transcending Physics and Chemistry. One was published in a relatively low-key journal, the other one was published in Science. But they are papers, well, if you're vaguely involved in science, look up Polanyi's stuff. You will find him hard to read, but at times you'll find a wonderful resource of thoughtful, integrative science philosophy. And he was a churchman. He worshipped. He was an Anglican. I think he came out of Jewish Europe. His roots are Jewish, I believe. But his writings are incredibly helpful if you want, and I want to just tell you a little bit about his approach. And this is this slide here. I don't know whether you can see it from the back, but look, we're going to start with, over here on the top left is a typical ceramic structure that you will find in most minerals found on the Earth's crust, basically silica tetrahedra. And in this case, we've got three of the corners of these little pyramids there, the silica, oxygen-silicon combination, covalently, ionically bonded, mixed bonding. They form little kind of links, and if they're linked at three corners, you get, in two corners you get sheet structures. If they're linked at three corners, you get, you get ring structures or fibre structures. So something like asbestos, it would form from this. Most of our clays contain this same kind of structure. And here is some clay. And of course this is kaolin clay, nice, very nice flat plates which reflect the type of linkage. Now those don't need to design that. There's no thought that you have to kind of get apart from the laws of chemistry themselves, which of course, again, where do they come from? And we don't need to get into that particularly. But the lawmaker surely is basically the source of that. But the important thing is that you can get clays, and then you can take that clay and you can mould it. Now you wouldn't use that clay, you'd use a much cruder clay. You wouldn't use lovely kaolin, you'd use refined china. But let's say we make a brick out of our clay, and of course that's a pretty simple, primitive object over there. But it's nonetheless, it's got the Auckland Gas Company imprint on it. It's got history, and obviously someone made it. And then you can take those bricks and you can build your stately mansion. Now, in one sense, our stately mansion is nothing more than a whole lot of silica tetrahedra. See that? But you certainly cannot predict this thing here, this more complex system here, which is a house, from there. Basically, what you've got is what Polanyi would have called a profoundly informative intervention that took you from there to there to there and to there. There's no other way you're going to get there. You cannot get your stately mansion simply by having the laws of physics and chemistry giving you the bonding between those silica tetrahedra. So there is that, what he describes as a hierarchical system. And he describes it in terms of dual control. Yes, the laws of chemistry and physics are required to give you basically the silica tetrahedra. You cannot do without them. But what you need is to impose on those laws boundaries, and they are boundaries that arise out of basically a profound informative intervention, which finally gives you this stately mansion here. So there's that kind of, and he's very strong on this, and I don't know whether anybody in more recent times has put it into more common parlance, but basically it is a very helpful way of seeing that complexity is it's not just complexity, it is something that has a functional end. And that's what we've got here. We cannot get that simply by using the laws of physics and chemistry. They operate at a lower level. It's hierarchical. It's the same, I use the analogy of the university. Right at the lowest level, and sadly, and they're not very well paid, are the cleaners. They come in at night. And you don't go to the cleaners to find out what the aim of the university is. You have to go much higher up, to the academic and to the... But the thing is, higher institutional structures are basically dual controlled. You operate, you have people, you have the technical staff, you have the things being made, but of course that feeds into the research ideas, so it's very much hierarchical. You cannot actually formulate the idea or the aims of a university or a sophisticated institution like a university or a hospital by simply going to the lowest level. They serve rather than define the purpose of the university or the institution. Very important principle. Here's another one which comes straight out of my own area of materials science. This is graphite. Now most scissors, you'll find a lot of scissors are made out of graphitic iron. Not simply because it has a lot of stuff in there which is very, very hard. It's not all hard. In fact, the softer stuff in there is made up of repeating atoms arrayed in that sort of structure up there, that what we call body-centered cubic. But again, I can give you an explanation in purely energy and composition terms as to how this structure of cast iron develops. There's these sort of tentacles here, the graphite, which is common. Not always. Cast irons don't actually have to have free graphite, but many of them do. And I can give you an explanation in purely metallurgical, sort of physical laws, or metallurgical laws, but I cannot, those laws will not define what the end thing I've made, which is a pair of scissors. I didn't make them myself, but they've been made, manufactured, and they're made there. They're not the scissors that structure comes from. They're another pair of scissors that I use. They're not quite matching, but the same principle applies. Again, it's hierarchical. Yes, the physical materials, laws of material science can explain this in a perfectly unthinking way. But when I want to go to there, far on the left there, I'm going to have a profoundly informative intervention. I cannot get away with it. So Dawkins, of course, is wanting to give get people to think, well, look, we've got all these living things. Do they really need a designer? Do they really need a transcendent being who thought them out? So he did his little, he wrote this little program, and basically what it did was made a whole series of, I can't remember how it works now, but basically a whole series of steps on the computer, and you could vary the angle, you could vary the sort of turns that it made, and he did it, set it off at random, And he got all these wonderful things here. He got a Spitfire, and he got a cross-sabred swords, and he got an insect with 8 legs and fox and so on. And he said, when I wrote the program, I never thought it would evolve anything more than a variety of tree shapes. I had hoped for weeping willow, cedars of Lebanon, very sort of biblical. Lombardy poplars, seaweeds, perhaps deer's antlers. Nothing in my biologist's intuition, nothing in my 20 years experience of programming computers, and nothing in my wildest dreams prepared me for what actually emerged on the screen. I cannot remember exactly when in the sequence it first began to dawn on me that an evolving resemblance to something like an insect was possible. So he saw them, he called these biomorphs. Now, that is a worry, because a number of colleagues, when this book came out back in the, I think 1980, I think when it was first published, if I recall, they were quite taken by it, thinking, oh gosh, so there's something going on here. We're getting life. Of course, this whole thing is just it's just on a computer, which of course had to be thought through. I can do it without even a computer. These are my biomorphs. Now, can you see what they are? What's that one on the top left? It's a whale tail, actually, not a fish. But no, joking, it's all right. It's a fish tail. What's this one here?
Propeller.
Yeah, out of balance propeller. What is this one down here?
Kangaroo sighting.
Yes, the two, well, it could be a dinosaur, but they're having a little time of intimacy. Now, basically, these are my biomorphs, and I didn't do my computer. All I did was I took a drop of salt solution, a mixture of 2 different salts, and let them evaporate in a warm room, and lo and behold, put them under the microscope, and I've got my biomorphs. Again, nothing. Now, there's no way that I would say I'm on the way to imagining how life began. It's just simply stupid. And that's the kind of thing that Dawkins is trying to, I think, convey in his book, the idea that you can just through random processes get something that hints or is symbolic of life. I would never, okay, these are like crayon drawings in a way. They're very primitive, but I thought they are rather telling in the sense that they it tells you what you can get simply by allowing natural laws to act in in this case, in a solution, salt solution. This one here, does anybody recognise what that is? I found this. Has anybody seen it? It's up in the Wongaparoa. And I've never been back to visit. It's a human face sculptured out of the purely unthinking action of wind and tide and rain and sand kind of eroding. And I thought, and I caught it just in the right light, and there it is there. It's probably now eroded away, but there it was. I captured that thinking it was a pretty elegant kind of biomorph. But again, I would never ever say I'm anything near creating life. It's the silliness of it that really gets me. The other approach that's used, and it's not unrelated to what I've shown previously, is this. In this case, this is a Japanese-American biologist, Douglas Futuyma. Biologist systems, like non-living systems, are ordered. Now again, this idea that order can actually give us... See, what the materialist is trying to do is to find a way of getting something akin to the complexity of life. That's what they're trying to do. Biological systems, like non-living systems, are ordered, and like non-living systems, they can be explained in terms of detailed physical mechanisms. Physiologists may be daunted at times in attempting to understand how a cell carries out the intricacies of metabolism, but as physiology has grown, it has shown these intricacies to be the consequence of fairly simple laws of chemistry, not a mysterious life force. So again, we've got this very strong thrust to explain without recourse to something special. And he uses 2 things. He says, look, go to the beach, and you can see that if you are pounding beach, you'll see fine pebbles here, coarse pebbles there. We've got an ordering system. So we can see it, you see. This one down here, salt crystals. which I took under the microscope. But salt is basically sodium and chlorine ions in a kind of a structure which I've just shown you there. They're sort of what we call face-centered cubic. Here is a crystalline salt, grain of salt and so on that have crystallized, well, that have basically, the habit form, their external shape reflects, of course, the positioning of the atoms, or the ion, should I say. And this one here is another one. That's that one over there I photographed. It's probably a bronze type metallurgical alloy, and you've got lovely fir tree pictures, again, a sort of a Dawkinsian image, if you like. This one here is Robert Hooke's frozen urine, which is lovely. He drew it, he went out, he obviously did a pee in the night, and then he came out the next morning and found it had frozen over. This is Robert Hooke, way back in 1600s, of course, 1665. And you get these dendrites growing, and he drew them. Now, it's a lovely thing to do, to sketch your own frozen urine. Lovely sort of things you can capture in life. But again, these are all examples of beauty and order, but they don't give us basically what we need to get basically purposeful systems. I could, on the other hand, take those same grains of salt and do something with them. I can put them in, I'm using, in other words, what I've got here is exactly what Polanyi was talking about. The salt grain is a consequence of bringing sodium and chlorine ions together. They form a particular, the chemical nature of those ions is such they form a crystalline structure which has a cubic habit externally, and I can put them into an order. And you can see there's two levels of explanation. The raw material, if you like, is got from our natural laws, but the actual order that I put them in is a result of a profoundly informative intervention. I've written out the word order. That's not that clever, but you can see what I mean. And I think that's where Polanyi is so powerful, that you've got to see that it's basically, we impose boundaries. I'm imposing boundaries of position on those grains of salt in order to give me a message that has meaning. That has meaning, because you can see it says the word order. Climbing Mount Improbable, again, Richard Dawkins, and this is where he, now basically he takes, what's the time, where's the chairman? How, I've got a...
10 minutes.
All right, okay, I think we're not, I don't know where I am, but I'll finish there. A paper was published in the Royal Society of London Biology journal, in which they created a virtual eye, and the virtual, oh no, sorry, I've done something wrong here. Right. And basically, what they, on a computer, they create this, so it's all virtual, there's nothing real about it, but it's made up of 3 layers. The top layer is transparent, so the middle layer is cells, and the bottom layer is a pigmented layer. And the idea is that the computer program at random varies the refractive index of the top layer, and also the curvature of the sandwich itself, you can see it changing, and also the diameter of the pigmented layer, which wraps around to form an aperture. And they found that after so many 100,000 iterations, you went from a flat sandwich layer right through to a virtual focusing line where you've got basically the structure in here which allows the light refraction. And they claim that, and of course they say, well, there we are, we have an explanation for, in principle, how we can actually get complexity, functional complexity, out of basically random changes. Now, Dawkins' conclusion, he takes this up in his book, Climbing Mount Improbable. Going upwards means mutating, in other words, making these random changes, one small step at a time, and only accepting mutations that improve optical performance. That is disallowed. In a purely impersonal world, where there is no purpose, where there is no mind, there is no goal that is being sought, you cannot add to your model accepting mutations that improve optimal performance. The moment you do that, you have admitted to purpose. You've admitted to a structure, a system, a process by which you are aiming for something. And the materialists will say, we're not aiming, we just get it. We're not aiming for it. And I think that's why I think it is a cheat. It's misuse of language. And so, now I'm afraid my cartoons are not the hottest, but I've done my best. And this is as if Tenzing and Hillary got to the top and said, well, here we are, Tenzing, on top of the world. You would think we had deliberately planned this. Materialism basically says we get to the top, there's no plan for it, it just happens, you see. And I think that's where I feel that what we're confronted with is a worldview that says there is ultimately no purpose. We are simply we are simply chance products of a unthinking, impersonal, unfriendly universe. And then there is Lewis Wolpert, who was a developmental biologist at the University of London, University College London, I think he is. I will show you that there's no master builder. He did the Rob lectures back in about, I said probably 10, 15 or even more years ago, I'm not sure, but he was here as one of the winter lecturers, the Rob lecturer. I will show that there is no master builder in the embryo, no vital force. Each cell has its own developmental program that makes use of a limited number of processes that have been used again and again for hundreds of millions of years. Now it goes on here, if you look at this, if the cells in the embryo know where and when to change shape, contract or move, then it begins to be possible to envisage a program for the development of form. It becomes possible to think of accounting for all the changes in form of early sea urchin development. Now, in terms of a changing pattern of cell contractions and cell contacts. The reason we use, or a lot of the early embryological studies were done on sea urchins is because they're very simple, relatively speaking, and they're transparent. You can see the way that the cells divide and form eventually the thing called the blastula. We can think of this pattern of cell activities as being part of the embryo's developmental program. It's a program that does not describe the final form, but a generative program that contains the instructions for making the shapes. A key feature of a generative program is that it can be made up of quite simple instructions and yet generate very complex forms. And that's true. You only need to give one little click on your computer and you will get something very different. And that's the nature of these kind of generative programs. And we are familiar with that. But, just go on a wee bit, this is his picture of the cell, fertilized cell divides repeatedly and eventually forms a blastula of about 1,000 cells, hollow ball, and then the cells at this posterior end actually start to migrate inwards and upwards, and they then start putting out their feelers and then tugging back on this top part here, and this pulls it in, and eventually it actually pulls it right in and creates essentially the alimentary canal of the animal. And Wolpert, so just go before we finish, Wolpert argues that it all happens just with very simple signals. And the other thing he makes a point of, the winner seems to be, this tug of war that goes on between the cells as they move up and they pull down, they put their feelers out and so on. The winner seems to be determined by how strongly the extensions adhere to the wall, and the cell eventually moves to the site where the attachments are strongest. It's not, this is what he says, it's not unlike climbing out of the sea onto a slippery rock. One comes out where one can get the best grip. Well, again, that is cheating. There's no such thing as a best grip. It cannot be. That is putting again direction, putting a directive, a purposeful directive into the equation. So I had to do another cartoon for this, and this said, strange that I should find myself leaping onto this rock. Strange. Yeah, it's not so strange, is it? You see what I mean? That's I think, the dishonesty of so much. Walpert has his cells doing even more than merely groping with their Philippodia. These are these extensions they put out to grab and come down. They're always exploring the environment. See, there's purpose again. They seek stability. Further on in the chapter dealing with pattern formation, he would have the reader imagine conversations between cells in which they declare their locations with respect to each other and to some critical reference point. This is actually something out of my book, so you have to, I've kind of taken what he said and put it into a context. This blatantly anthropomorphized behaviour is then reinterpreted as resulting from vaguely defined processes involving diffusion of chemicals along concentration gradients. Now he realises that he can't go too far with that kind of language because he's got to come back to something like it's all just vaguely defined diffusion gradients and so on, which of course is most unsatisfactory. So he sees the embryonic shaping process in terms of quite simple instructions contained in what he calls this generative program. Now, in one sense, he's perfectly correct. A simple command can produce very complex changes in the behaviour system. This is only because the generative program which provides the shaping instructions is a highly sophisticated information receiving and responding system. Walpert fails to point out that generative programs don't come easily. They require a very large investment in programmer intelligence and creativity. But the reader is instead left with the distinct impression that simple instructions are sufficient. So that's the sort of trick that's played, I think, on the reader. And I love this one. This photograph, this is one of Blaise Pascal's calculating machines. Now his father was a tax officer, and Blaise had to do all these calculations on paper, and he said, no, I'm going to make my machine, make it easy for myself. And you can see those, that's one of the photos, it's in the little museum of arts and trades in Paris. And this is what he says: to make the movement of my machine's operation more simple, it had to be composed of a movement the more complex. You see that? So when Walpert says we just need simple instructions, he uses the example of a jukebox. Now, I don't know whether we have jukeboxes now, that's probably still in pubs. This place had one, didn't it? It was a pub originally, I believe, isn't it? Did it have a jukebox? You have one out the front here. A great illustration and you press a button and you get a song, but of course pressing that button invokes a whole complication of mechanisms that have all been beautifully constructed and orchestrated. But there's Blaise Pascal, he saw it, he understood it. Look, I think I might leave that. Just to say that Polanyi comes back to mechanism, and here's two examples of mechanisms: my curling finger, and also a very simple early schematic of an internal combustion engine. Polanyi says this: there is a great deal of truth in the mechanical explanation of life. The organs of the body work like machines as they are subject to a hierarchy of mechanical principles. Biologists pursuing the aim of explaining living functions in terms of machines have achieved outstanding success. But this must not obscure the fact that these advances only add to the features of life which cannot be represented in terms of laws manifested in the realm of inanimate nature. In the same way in which the material properties and inanimate laws of nature are harnessed within the boundaries defined by the design of our man-made machine, so the inanimate molecular and chemical laws operate within the boundaries defined by the organism's structure. But this living structure is no more determined by these laws than the material properties of steel determine the shape of a crankshaft in an internal combustion engine. So there's the matching image, if you like, between inanimate mechanisms, which cannot be explained without this hierarchical principle, and of course animate or living organisms, which again require exactly the same kind of dual principle. Now, the other writer that you really should try and read if you're again interested in this area is E.W.F. Tomlin. He was an essayist. He worked in the British Civil Service. He was a Catholic writer, scholar, philosopher. And he writes on the concept of life in a number of interesting articles. So E.W.F. Tomlin is well worth looking up. The living organism is goals-oriented. It initiates novelty. It seeks to realise its full potential. It is able to take measures against the future in a manner entirely denied to an object. It can provide for the future by reproduction, by repair, following injury, while all the time engaging in self-maintenance in the midst of an ever-changing and often hostile external world. A lovely, brief statement of just what it means to be alive, entirely denied to a living. And so how do we go from the non-living, the inanimate, to the animate, and have all this here, which is we all know something about in life experience. The other one is from Broom. He was a systems scientist. The living organism heals its own wounds, cures its sicknesses. It may rebuild large portions of its structure when they have been destroyed by some accident. This is the most striking behaviour. Think of your own car the day you had a flat tyre. You don't have many these days. And imagine having simply to wait and smoke a cigar like this. And while the hole patched itself and the tyre pumped itself to the proper pressure and you went on. That sounds incredible, but it is, however, the way nature works when you chip off while shaving in the morning. And there is no inert matter possessing a similar property of repair. It's just the idea of just thinking about being alive and asking, do we have an adequate explanation for it in terms of purely scientific, kind of physical, chemical. Here's a little bit of slime taken from the pond in the domain. Put it under, it's a little Proteus amoeba, and it's sitting there on my slide under the microscope. And then I actually took a bit of blotting paper and got and this has got no central nervous system. It's just the most primitive of creatures, just sort of slime that you would just think, oh. And yet when I had a little flow of current with blotting paper soaking the water one way, it put out its little feeler and said, no, I want stability. I want to be. And that's a lovely thing about life. It has this sense of wanting to be and to become. A lovely idea. And I think the metaphor of orchestration is so important. In fact, I think Tomlin actually talks about this in his writings. But the idea that it's all about the tune that's being played. Yes, we've got the physical laws which represent the different instruments, but it's when they're played in tune, they're played to a melody line. They're played anticipating what is yet to come in the score. All those things are part of being in the living world. Now, the other writer that is well worth reading, again, he was the zoologist at Oxford, I think it was. Yes, Oxford. And he gave the Gifford lectures back in '63. I think Polanyi gave them a little later, actually. But Hardy is very interesting. And I don't know how orthodox a Christian he was. I think he set up the Centre for Scientific Investigation of Religious Experience. But he certainly, and this is, he makes reference in The Living Stream to these incredibly simple organisms called, what are they called? Asteroizid foraminifera. There you are. And what they do, they're just like little bits of slime, like that amoeba, very similar to amoeba. And they actually go and they construct little houses for themselves. And they will pick out little fragments of grit from the seabed and they will place them in the right way to make a little test or shell for themselves. Now, can you imagine what's going on in that little creature's mind? It's got no central nervous system, no brain, and yet it actually does these incredibly precise, it constructs its own little stately mansion. So there is one of the wonders, and Hardy actually, to my mind, these various foraminifera present one of the greatest challenges to the exponents of a purely mechanistic world view of life. Here are minute animals without definite sense organs such as eyes and appearing as mere flowing masses of protoplasm, yet endowed with extraordinary powers. Not only do they select and pick up one type of object from all the jumble of fragments of other sorts on the seabed, but they build them into a design involving a comparison of size. They build as if to a plan. There must be an instinct of how to build and some sort of memory as to how far they have filled in the spaces and what sizes of spicules remain to be picked up to complete a section. A lovely, just taking something that, you'd never get a TV program on this now. This is just it's too profound. That's the problem, it's too profound. And life is upwardly I've yet to go down. Anybody been to the bottom of the Grand Canyon? Not by helicopter, but by walking. Has anybody done it? Tell us about it. Did you come up? Did you walk up?
Yes, I walked.
Did you see the strata? Did you see the fossils as you went up?
I saw some, but not a lot. I was alone and I had no one pointing them out.
Yeah. You were probably very hot too, were you? Very hot.
Yes,
Well, you've got to go back. But here's something. This is my last slide. And here is a. Now it's from a book called On Holiness, actually, historian and theologian Donald. And I don't know. It just struck me as something well worth just thinking about, because it kind of takes you back to a kind of almost evolutionary naturalism, but there's something in it which is, I think, very stirring. Observing the traces, he walked up the Grand Canyon and was observing the fossils and so on. Observing the traces of them in this way, you feel a true kinship with all those beings, knowing that both they and you trace their existence, that first moment of transcendence when life appeared on the earth. Then you start to reflect that the very eyes with which you are observing these wondrous evidences are themselves the results of millions of years of striving for life. Striving, good word there. Ever since the first pinhole eye appeared on those primitive marine creatures, the cephalopods, that is. And you are the beneficiary of all that struggle for light, the heir of all that agony. And as you gaze at your hands, or think of your ears, or of your tongue, it takes your breath away to envisage the innumerable strivings that had to be attempted before you could see and touch and hear and taste and speak. Had any breakdown in that series of stirrings occurred, it would have destroyed the possibility for you to see and hear and sing. The breakdown was prevented by untiring faithfulness on the part of millions of beings. The mere thought of this makes you realise what an incredibly hard-won privilege it is to simply be a human being. And at the same time, it's an awesome responsibility. Every human being has a responsibility towards all those creatures whose agony and groaning has given him birth. So that's my last slide, and I think and again, I don't know what you do with that, but it just seemed to me to be an appropriate sentiment to express, particularly if you're talking to someone who's a hardcore naturalist and doesn't sort of see the beauty of that incredible unfolding of life that has given us. Yes. So that's it. Thank you very much. So, I don't know whether you've got any arrows you want to fire at me.
One of the problems with the computer generation is how do you bring in adaptability? How is one word more adaptable than another? There are so many problems with doing things on a computer. You mentioned that with various people trying to do that.
Right.
A lot of problems with it.
Well, you've got to write a program in the first place.
That's right.
Exactly.
It has direction.
But in the case of Dawkins, the things that Dawkins produced were simply shapes. And he has invited us to use our imagination and relate them to objects in our experience, which are complex living organisms. And that's, as you pointed out, it's just silly.
Yes.
When you say there's no such thing as simple life, how simple is the simplest form of life compared to, say, a cell in a human being?
Well, who's a biologist here who could answer that? I can't. I mean, you're a biologist. You're not. Come on, you're certainly not. Yes, I mean the earliest, for example, up in above Shark Bay, Shark Bay up north of Perth, way about 1,000 miles north of Perth. I think they've got these stromatolites, and these are thought to be basically almost unchanged from 3.5 billion years. And so the slimes that we know, what grows on your inside of the fish bowl, is a slime very similar to the slime that actually formed, and it has very largely unchanged. Now they're made up of cells, so you can't sort of have a half, you can't have a Dawkinsian half cells. However primitive it is, it has to be an integrated system that works. So you can't have something that is almost there. It's got to be there, as a functioning system. But of course, we've got a whole, cells that, the cell that we showed the blastula and that's obviously relatively complex compared with, say, the algal sort of cells that form those stromatolites. So I can't answer that. I don't have enough cell biology to really. The thing is, it's a going concern.
I'm really driving at the idea that you can form life from non-life, starting with something very simple and then getting more complex.
Yeah.
So I'm just interested in trying to tie that down. Give examples of how simple life is possible to be.
Well, of course, the early work that was, I think, following Miller's experiments, there was quite a lot. There was a big thrust to really try and create the first living cell, and they got these little spheres. They got very excited because they got these spheres that appeared to be cell-like in shape, and they thought, we've got onto something. It turned out to be a completely erroneous claim. But yeah, I mean, trying to make a cell is like trying to. As far as I know, a cell has never been created, even with all the human endeavour that has gone into it. And it's quite a big science. It's like the origin of life science. They're still really stuck on trying to get polymer chains to replicate or vary to give you kind of variability which can be copied and then to get reproduction and so on. So it's quite a complex science. And so there's a paleobiologist in Cambridge by the name of Conway Morris. Some of you probably read his book. And he actually delves into it in quite a significant way. And he's very, very, he's pretty tough on Dawkins, actually. And he would be, I believe he is a Christian, actually. But he's very much in the camp of science and trying to push the science as far as you possibly can. And that would be quite a good source to actually read if you're interested in sort of the sort of difficulties involved in origin of life's research.
Thank you.
Miller's experiment has been discredited now, hasn't it, for lots of reasons.
Yeah.
Processes which create the molecules also destroy them.
Yes.
And the chemical conditions would be different from the chemical conditions originally on Earth, So that's all gone by the board.
Yeah.
Just mainly the historical interest now.
So
apart from that, it was poisonous. They would kill you.
Yes.
And secondly, man can make amino acids in and we can make 100% dextro rotary or levo rotary. We can't make 50-50. Nature makes 50% with polarized light, but it goes one or the other with nature, with mankind.
it's a very well, I mean, the science. I mean, if you're a scientist and you're a naturalist, you're trying to get an answer to the mystery of life by natural means. That's the motivation. And there's nothing wrong with actually doing the science. It's the question of how far you're prepared to go before you say, look, it's not working. It's causing. We're having to. The very fact that you're a scientist in trying to create life, of course, is a major problem, because here we're bringing profoundly informative intervention into into the laboratory, where we're actually doing things, we're manipulating in a way that we shouldn't be if we're wanting to actually have a purely naturalistic